So let's just start. By show of raise of hands, how many of you are in their daily job somehow connected to .NET, writing software, building stuff? Just, okay. To set the stage a bit for this talk, I'm going to talk about the .NET supply chain, as the title actually says, but I'm going to dive into a lot of, hopefully for you guys as well, hidden features that are actually present in .NET, in NuGet, which aren't that obvious to find. Some are. And let's dive in. But for the people who are actually able to read .NET, so let's say I have this demo project here. I have this simple project file which is referencing newtons of JSON. Is this readable for everyone? Bigger? I can also switch to dark mode, which is the preferred mode, but I'm not sure if that... Is this better for you? Okay, great. Simple reference, newtonsoft.json, version 13.03. I can even show you it's an existing version from a few months ago, of a few years ago, sorry. But it's an existing version, so I'm not tricking you there. I just have a simple person class, which I'm serializing and then writing to the console line. And my person class consists of a name, an age, and an email. Can anyone spot something weird in this code? Like, this could be something you can write yourself, maybe, or not, if you have a better way for doing this. But on the, at first sight, it just looks like a normal serialization of objects, right? And it actually is, but let's see what happens if I run this project. And there were some talks this morning already about supply chain and stuff, so you know, hopefully, that stuff is going to happen here. And you can imagine that there are worse things than showing NDC Manchester your terrible taste in music. Like, for example, looking at the current state of the internet and everything that's going on there with Shai Hulud, for example. Opening Spotify is a simple, easy thing, but there are more serious things going on as we speak that can happen to you if you're using the wrong packages. And today I'm going to show you all the features that are in NuGet and in .NET that can help you harness against using the wrong packages, identifying when you do, and to be able to mitigate them in an automated way so that you should be less vulnerable than you are out of the box using .NET. But there are also known vulnerabilities, right? The biggest CVE in history of .NET in like 4, 5, 6 years maybe. 9.9 on a scale of 10. Everyone saw this one, everyone fixed this one, hopefully, right? I see some people maybe, everyone recognized this one, right? Who is doing .NET? Not? I only see 1, 2 people. Okay. If time permits, I'll show this, what the impact of this is, and that you guys have some work to do if you haven't fixed this one yet. But let's go back to that one later. Supply chain security and the supply chain attacks actually started with the biggest, well, at least the first known supply chain attack was the SolarWinds attacks back in 2021, where attackers got access to the build machine of the Orion software, which is distributed to all kinds of US government stuff and so on, where they weaved a certain backdoor into the software, what's coming out of the build server. So everything on your local machine was fine. Everything that was shipped to customers actually contained malicious software, which contained a backdoor in all the government software. A more recent example of this, and how many of you saw the session of Niels Stanis this morning? Okay, great. Then I'm telling all kinds of new stuff. In April 2024, there was this one engineer from Microsoft who saved the world, was the headline, and he might actually have, but because what was happening there is the XCutils package. Anyone familiar with this package? Great, a few people. This is a package that's used in a lot of Linux distributions all around the world. The software is running on Linux, and everyone's using it. And there was this Jihad75 contributor who made his first commits in 2022. And he did a lot of cool stuff. He built a lot of new features, so the community actually trusted this person on being a contributor to the XE-utils package. And suddenly this, somewhere around June 2024, his commits stopped. And if you are a quick thinker and you look at this date of April 2024 and the June 2024, there is a connection between that, because this contributor, a trusted person in the community, actually built a backdoor, or actually tried to build a backdoor into the XE-utils package, which was almost distributed across the world in running to, deploy to all your production softwares as well. The person who found out was doing some kind of regression testing and saw that the timings of their Postgres testing was off and started looking into it more. But yeah, some simple examples from the past, which are actually kind of risky, I think, and not sure many people are aware of the cost of using these packages and using other software that's written by someone else in their production environment. Cool. So, who am I? My name is Tom van den Berg. I'm a lead software engineer from Info Support in the Netherlands. I have become a father 2 months ago, so this is the first time I'm away from home. It's a bit, it was a bit scary for me as well to go away, but I'm happy to be here. And in my daily job, I'm currently building a platform. I'm a platform engineer currently for the Dutch railways, where we build a Azure-based platform for all the software that's running the trains every day. So if there's some kind of Dutch headline saying the trains are not running, it might be that I made a mistake. Enough about me. Let's dive in a bit more. So who's not from the UK here? A few people, cool. Are you from the EU? Well, sorry? Norway, okay, so you're from the EU and do you know the Cyber Resilience Act? That's a thing in the EU? Okay, great. For the people who are UK-based, since you split it off, you are no longer obligated to comply to the EU government and the EU laws. But there is a new, if you look at the date, the 12th of November 2025, less than a month ago, and I'm currently being called, sorry for that. Less than a month ago, the UK government also made some really tight new changes to the laws where, not really?
Not the same, that's NIS2. That's the equivalent of NIS2, not the CLA.
Oh, okay. I did a brief, small investigation, and this is where I came up with, but there are some new laws who are... Okay, they're not... Okay, great, thank you for the feedback. I tried to put it onto the CRA, but does the UK have something like the CRA?
We don't have anything perfect with CLA.
Okay. Well.
I do CLA briefly.
Okay, great. Ignore the previous slide. It's different stuff that you do need to think about it, I guess, but it's not related to the EU CRA stuff. But in the EU, there is this new Cyber Resilience Act, which actually states that there are certain stuff that you have to comply to as a software vendor, and if you are marketing software in the EU. So this means that each product needs to have a risk assessment, and that means that you can provide evidence that there are no known vulnerabilities in the software that you ship. That you do security reviews, for example, that you have certain documentation about if there's a vulnerability found, how do you handle that? There's this SBOM file, the software bill of material, which we're going to touch upon briefly today. Depending on the classes that you fall in, and I'm going to skip to there are 3 classes that are defined. So we have the non-critical class, and for non-critical it means you can do a self-assessment to these things. That's nice. But if you're in the critical class 1 or 2, and it depends on the impact of your company or your product for the infrastructure of the country. And let's say, for example, the Dutch Railways is a company where is the backbone of the Dutch traffic each morning. So if there's something wrong with that, the whole country could fall still. It's a bit overcommitted, but yeah, there is this certain level of criticality to the business that we do. So we will get an independent external auditor who will look at these things for us. And there's this new obligation that if you have a vulnerability found in shipped software, that there is also a reporting obligation to ENISA, which is an organization where you can put in those, where you have to report this. So for the EU-based people, the first thing that you have to obligate to starts from September 11, 2026. So within a year, less than a year, you have certain obligations to comply to. Otherwise, you will get serious fines. And those fines are, we have the GDPR fines, which are okay-ish. These security fines are 10 times, maybe 15 times bigger than the stuff that you can get fined to for GDPR violations. So if you are not already aware of this, know that this is a new act where, well, September 2026, you're up for the first compliancy stuff. Cool. Questions about that? If not, then I'm going to continue. What we're going to talk about is the software supply chain, and a supply chain encompasses all the materials, resources, and processes involved in the creation and delivering of a product. So it's not just the packages that you're using, it's not just the stuff that you're running, but it's also included in the process, and it also includes all the stuff that you pull in, everything that's involved in the process. And what's interesting in that is that software is no longer built entirely in-house or runs on software on code that's written by the team itself. And this morning, Niels showed the percentage that 80% of the software that's currently running in production is not written by people who are working for the company where the product is from. So you're all relying on, for 80% on stuff someone else has written. And that's a bit scary, right? If you saw the news articles that I just showed you, and then think of, hey, 80% of the stuff that we run in production is written by someone else. What's in my software, actually, that I'm not aware of? And is there something that I'm not aware of, and should I be aware of something? So looking at .NET, where we're going to focus on today is, so let's say we have this top-level R project, the product I just showed you. And the product has certain direct dependencies in this case, the NuGet packages that you reference in your CS project file. These are called your direct dependencies. And these dependencies can have transitive dependencies themselves. And the tree on this can become quite large. Right? If you have, I'll show you in a bit a command where you can actually see your entire tree. But what happens if a vulnerability or malicious software is injected into one of those transitive packages? Anyone around with the Log4j issue a couple of years ago? Cool. Log4j was also there was this quite big CVE found in Log4j, and the whole world stood still because no one was actually aware, are we using it or not? So I got a call from my manager, and he's saying, do we have problems? Do we use Log4j? And I was like, I don't know. And that's where it started for me, by diving more into this subject as well. But there are more people, and I think there's some people in the front I saw a bit smiling. They can relate to the question maybe. And also ask yourself, was I aware, or am I currently aware of everything that's running in my software? And if I get that call, am I able to answer the question, are we using this? Okay. So let's go back to some demo stuff. Everything I'm going to show you today is starting from .NET 8 until the new .NET 10 release. I have some cool features that have changed throughout the time, and some features that are introduced new but are not enabled by default. So I'm just going to show you some stuff. So .NET list package is the first command we're going to look at. And this is a quite simple command which, if it's built, it will show all my top level, it states here top level dependencies, and these are the direct dependencies, so dependencies I have defined in my CSproj file. I can then ask, give me the transitive ones as well. And this list becomes bigger. I see, hey, I have all these dependencies I get for free because I use those top level ones. That's okay, right? But what if .NET can also tell me if there is a vulnerable one in there? Oh, I have 2 vulnerabilities. This morning I only had 1, I think. I have 2 vulnerabilities. And vulnerability information is, well, it states which package does the vulnerability have and what is the vulnerability information that, what is the CV, how can it be exploited, and all kinds of information that you want to know about vulnerability can be found here. So knowing what's in your software. For the log4j example, where I got the question, hey, how do I know what's running in my software and am I using this? .NET introduced, with .NET 9, there was this new feature introduced, which is .NET NuGet Y. This one. Which you can give a solution and then give it the package that you want to know how you're using it. So in this case, .NET NuGet Y system.txt.json. I get a tree which tells me exactly via which way I get the system.txt.json package included. In this case, it's included via 3 different ways. But here you get a quick answer to the question, hey, are we actually using this software? So what if the .NET build command would actually tell me I have this vulnerability, right? We saw I have 2 vulnerabilities in my software. And starting from .NET 8, there was this new introduction of NuGet Audit, which I disabled here because of demo purposes. But you might recognize, are there any Visual Studio users here? People who saw you have a vulnerability warning in your Explorer. That's this .NET NuGet feature, of NuGet Audit feature, sorry. So now if I run .NET Build, it will actually state, hey, you have these warnings in your output, which will say, hey, I have certain known critical severities and the stuff I saw with the .NET List package as well. Cool, .NET can tell me I have a vulnerability, nice. The default settings for this in .NET 8 was that it was only auditing my direct dependencies, so only the top level ones that we have. In .NET 9, they tried to change it to the transitive ones, but then they introduced a breaking change because a lot of people, what they did was, I'm not gonna, I get a warning, but I hope that my build will fail if I have a vulnerability. So what a lot of people did is they enabled the treat warnings as errors and then a bit more scope to the specific vulnerability ones. But if I'm going to build my solution now, it failed. So changing the settings, changing the default settings in .NET 9 to, taking a step back. So in .NET 8, they implemented this and then they updated to .NET 9 and the settings were still the same. And then with the patch release of .NET 9, so 9.0.200, I think it was, they tried to change the default audit level to all, which was a breaking change in the same .NET version, so they took it back. But now with the introduction of .NET 10, they actually set the mode to all again. So if you upgrade from .NET 8 to .NET 10, from LTS to LTS version, you will get a bigger list of vulnerabilities than you might have had before the update. And to show you that it's enabled without this, I can remove it and just update to .NET 10. I'm going to disable this one again. .NET build. And I get this information out of the box for free. So the direct dependencies and the transitive ones. Anyone already updated to .NET 10? Saw this feature? Cool. At least you learned something new. Check. Then I have one more thing, because are there any users of NuGet who are using a private NuGet feed? 2 people? 3, 4? Are you only using the private feed or also the public one? Okay. The vulnerability information that NuGet Audit uses comes from the public NuGet feed, and that pulls it from the GitHub advisory thingy. But with the introduction of NuGet Audit, if you only configure the private package source, then NuGet is not able to reach out to the public feed, and it was not able to retrieve the vulnerability information, so the NuGet Audit feature didn't work. In .NET 9, they introduced a new feature which is called audit sources. And audit sources is an explicit feature that tells you, hey, I have vulnerability information, and this is where you can get it from. So you can still configure your private feed solely to pull images from, but to get the audit information and the vulnerability information, you can go to NuGet or your own implementation of this, whatever you want. Cool. Knowing what's in your software, knowing what vulnerabilities are there, and reacting upon it. Back in 2008, there was this first case of a software vendor, Cisco, which was sued for copyright infringement. And that was because they were shipping software. Cisco, everyone knows Cisco, right? From the big old internet router stuff that you had at home 10, 15 years ago. They were sued because they were using all kinds of open source products in their product. And one of those packages that they pulled in had a GNU public license agreement in there, which means that if you ship software which has this license in there, you need to open source, or you need to add the source code together with it, or at least make it available to be read. Well, and if you think about this, Cisco is a company that lived out of building those routers, and that's what they made money from. So if we need to open source the software, we need to open source our entire business case, and everyone can start building routers using our software. In the end, they settled. They made a huge contribution to the OpenSSF Foundation, where as Cisco, they applied, or they made one person in the company responsible for these kinds of things, so that they are not infringing with licenses anymore. It's very interesting, something that started the whole discussion about license use in software. But taking this back to NuGet and the software that we're all building in a day-to-day basis. So what happens if one of your transitive dependencies has a general public license? Right? Are you aware of the licenses that you are using in your software? Or you might even be, okay, taking a step back. You might be using a license in production or a package in production that requires you to open source your software already. So this is quite scary. At least I thought when I heard about this, and I think it's quite scary that this can happen, and you might need to open source your software. .NET itself doesn't really have a license thingy yet, I hope. I don't have any inside information, but I hope that this is the next step that they will take in the NuGet's security stack. But there are other tools there that you can use. So in this case, and first need to enable a certain feature, which I'll come back to later. But now I'm going to show you a tool called Trivy, which is scanning tool, which does anyone know Trivy? Right, it's a scanning tool that you can use to scan your for vulnerabilities, your infrastructure, also for licenses. Scanners license dot. Cool. And this will actually tell you for all the packages that you have in your software, and I haven't built it yet correctly, I think, but at least you can see, hey, I'm using these dependencies in my software, and these are the licenses that they are using. And Trivy has a default configuration on what licenses are non-compliant, or at least have a high severity of being violated, and which one are a bit more free to use. So yeah, I would definitely recommend run this over your own solution to see what kind of licenses you're using and to see if you're in violation of any of them, because that might be a big issue for your company. Okay. Knowing what's in your software, being aware, and these are just the known stuff, right? Talking about using packages, there's this thing called supply chain risk management, and this all encompasses the way that you need to identify, assess, and prioritize, but mainly start with identifying and assessing the impact of using a NuGet package. So you can imagine that if you have a certain process which is in the core of your business, and for some reason they decide to stop maintaining it, or they retract it from NuGet, which is not possible. They retract it from NPM, so the package is no longer existing. What happens to your company? Are the trains not driving anymore because someone in Nebraska pulled their images of their NuGet package from NuGet.org? So there are different categories in which you can identify these risks. There are operational, can the train still drive? There are financial risk, business continuity risk, business asset risks, and these are all need to be taken into account while you add that new NuGet package to your supply chain. A great example of this is, and I think is this great is-auth package, which is a package which has more than 500,000 weekly downloads, which has a lot of people depending upon. And if you look at the code, it's just 12 lines of code. So you can imagine if someone retracts this one from NPM, there are at least 130 people or 130 projects who are failing to be built again. And what's even more funny is there's also this is number one, which has a lot more weekly downloads, which has even simpler code, mainly 8 lines, to see if a number is a number. Yeah. It might be that this is a bit for a jiggle, but people are actually using this, and a lot of people are. So be aware of the NuGet package that you pull in. The features, what I'm trying to tell you is be aware of the NuGet package that you pull in, where you're using it for, if you're using it to its fully extent, or are you just using a subset of the features. And then it might even be worth to implement it yourself or create an own implementation of it instead of relying on someone else maintaining this NuGet package for you. Okay. Going to the real bizarre, more scary part of the NuGet supply chain. These are all known stuff that you can see, and no one is doing something with you, right? Looking at the NuGet restore behavior, if I have one feed configured, this is what I would always recommend to any company I come. Please use a curated private feed where you're in control of all the packages that are in that feed. Because well, when I have one feed configured, the stuff I get is always from that feed. But I saw some raise of hands here that there are people who are using a private feed, which is great, but they're also using the public feed, right? Or people who are just using the public feed. I'll come back to you later. But what happens if I say, for example, I have this mycompany.common package which I'm trying to use, and it's published in my private feed, right? What NuGet will do, it will send an asynchronous request to each configured package source. And the package source that answers, that's where I pull the package from. But what's interesting with this is that, taking one step back, in this case, because there's only one package source that has the required package, there's only one that gives answer. But in a case of, for example, I, as a hacker, want to upload a package to NuGet which has the same name and hopefully the same version or a bigger one than that you're using, NuGet will send an asynchronous request to each package source. And then the first one that answers, so it's just waiting until the public NuGet feed is faster than your private feed, that one will be used. This is a tech called dependency confusion, where you're, which I showed you with the Spotify example in the beginning, right? I'm trying to pull Newtonsoft JSON in, but it's actually from a private feed, which is a bit faster than the public NuGet one. So that one's being used. And I can even make a reference from mycompany.common to mycompany.common and configure that you need to pull that mycompany.common one from, not from the public feed. So the functionality will be the same, but you're using my package instead of the ones that you're expecting. And what happens with floating versions? And .NET has some security on it, but I have seen a lot of people who think, yeah, patch versions, nothing can go wrong, right? There are no breaking changes in patch versions, hopefully. There are no big features being added in patch versions. No, that might be true. But if I publish a package which has a huge version bump, which is not touched upon quick, I think, with certain development of packages, you might be lucky and pull in my image. So it's just publishing stuff, waiting until stuff happens. I'm going to show you a few things that you can do against this. And there's also another thing which is called typo squatting attack, which is, I'm going to show you. So the first thing that you can do is, and I'm going to show it here, Newtonsoft.json has this prefix reserved tag, which states that the Newtonsoft dot prefix, or Newtonsoft.json, or you can make it as long as you want, prefix is claimed by a company, and they are so the only ones who can publish packages with that name. So even though you're not using the public feed, I would definitely recommend claim a prefix on the public one, so that no other hacker who wants to harm you can publish a package in your name. Small tip. To do so, there's this whole explanation on how you can do it, but it starts by sending an email. And then you can get started with claiming a prefix. .NET has other stuff that you can also do. One of the biggest things that you can start with tomorrow, hopefully, is adding a NuGet.config file. And I already showed the audit sources and the package sources. Package sources I didn't show, but those are the ones where you can pull images from, or you can pull packages from. And a feature in the NuGet.config file is package source mapping. And package source mapping actually states, hey, I want to create a map and tell NuGet exactly, using wildcards or using specific names, where I want to pull, from which package feed I want to pull which package. So in this case, for the Newtonsoft.json one, I stated explicitly, because I always want this to fail, that this package needs to be pulled from my own private feed. And I can actually show you without changing any code, but just removing this one and running the .NET build. .NET run. It's still failing, and that's because I missed a small part. And the thing I didn't tell you about is the local NuGet cache. So NuGet has caching in place, so that the first time you restore it takes some time. The second time you restore it, it pulls it from the local cache on your machine. And even though I configured it correctly now, NuGet will ignore the package source mapping because there's already a package in my local NuGet cache. So I'm not going to restore it from any feed. I'm just going to use the local one. And to fix that, I can .NET NuGet locals all clear. And then .NET build. It's failing. Oh, yeah, okay. Then my package log.json, which I'm coming back to in a bit. I'm going to disable this one again. So all these features are tying into each other, and if you're messing one thing up, then it's all come crashing down. So for demo purpose again, it's succeeding, .NET run. And now it should actually say, hey, I'm going to write it to the console. I didn't change any code, like you saw, but yeah, just by using package source mapping, I can actually be confident of which package I pull from where. Preferably only from your private feed, if possible. Let me see if I had everything from here. Yeah, another thing is the trusted signers. And trusted signers is a feature where you can configure a certain set of NuGet package publishers as trusted people, or trusted companies, or trusted publishers of that package. And this is interesting because if you're like me, adding packages to the command via the command line, so .NET package add, and then newtonsoft.json. Oh. You can already see I make a lot of typos, and that's exactly what the typo squatting attack is waiting for. So with the typo squatting attack, people are intentionally publishing packages with typos in the name to the public NuGet feed. So in this case, for example, Newtonsoft with the T and the N mixed around, or an O instead of a zero instead of an O, or even from a bit more Eastern with letters that are somehow similar but are differently in ASCII characters. They are trying to publish packages with those names and then just wait until someone makes a typo and restores it. And trusted publishers of trusted signers can help you by configuring, I only want to pull packages from these signers, and if I make a typo, the .NET restore command will tell me because I configured a package which is not published by a trusted signer. So this can also help you to be more resilient against using the wrong packages from the wrong publishers. Okay, we moved out of your local environment. We made a build, you saw the build succeed, and you saw the JSON being pushed out. And what you actually want to achieve is to have a reproducible build, at least have the build output on your local machine be the same, or at least be the same as the one that's coming out of your build environment. And there are certain aspects of your of your build process that that are in that process. So the .NET version, the .NET SDK version that you're using on your local machine, is that the same one as that you're using on your build environment? The NuGet packages that you pull in, the stuff that's in your NuGet cache, all these things are used in the creation of your .NET project. And what happens if on your build environment, for example, the cache gets injected with malicious stuff, like with the SolarWinds example? Or that was not a NuGet cache, but the build environment got got attacked, and via there they got a different build output. I already showed you a bit what you can do against it. There are more things. So the first thing is the package log file. Who's not using a package log file? A few people. So you guys are using package log files, hopefully. Cool. A package log file is actually is a file that contains certain data about the packages that you're using. So in this case, it will actually tell me, hey, I'm using newtonsoft.json as a direct dependency, which version was requested, which version was resolved, and then a hash of the content that's being used. So this file you can use to, in your .NET Restore, log mode, I think. Okay, it's right. The log mode is correct, but then if you tell it to use log mode, it will actually use the package log file to validate the hashes of the images of the packages that are being pulled in against the ones that are in my log file to validate that they are the same. So if there is a different version being used, or the same version with different content in there being used on the build machine, compared to your local package log file, your build will actually fail. The package log file is also a file that you commit into Git and then use it in your environment as well. It does mean that you need to use the log mode option in your pipeline to use this properly. So a different thing that you can do is there is this package which is called nope. This one, .NET Reproducible Builds, which is a Microsoft.NET published NuGet package, which alters certain parts of your build process. And there are a few things that are interesting in this. That is mainly the net core targeting pack route in this case. So why is this not working? Yep. Okay, the net core targeting pack route, and this will actually tell you, or will tell .NET to ignore all the installed SDK versions on your machine. And to show you how this works, this works, and what it actually does, I'm going to ignore my I'm zoomed in too much. I'm having to. Okay. Cool. This is a different error. Okay, let's ignore that. The net core targeting pack route will actually tell the SDK to ignore the local installed .NET version, and it will actually try to pull in a NuGet package from the public NuGet feed to use to build your software. That's why I was commenting out stuff in my NuGet config file, because I wanted my build to fail and actually tell you, hey, my build process needs this package so that you believe me. But in this case, you have to believe me or try it yourself. But you can actually change the behavior of the .NET SDK and what it's using to restore your stuff. And the second thing that the package does is it will actually tell NuGet to ignore implicit fallback folders. So there's a certain traverse in how NuGet checks your machine for cache is available. For example, the .NET or the C# builder will actually check in the F# cache to see if there are packages there to use. So that might not be the first place where you look, but those kinds of things, those kinds of traverses, you can actually disable by also setting these properties as well. So in combination with making sure that the software that you're using is the same one that you're using on your build machine by pulling it in via the public NuGet feed, and using the combination with the package log file where that package is also being described in. So the version that you use locally to build is the same one that you use on your build machine as also. Gives you more confidence in that the build that you create on your local machine is the same one, or at least using the same binaries that you had on your in your build machine, on your build server. Okay. Reproducible builds, I already showed you. So, in short, we looked at certain .NET features today. We looked at NuGet audit, prefix claiming, license validation, package source mapping, the NuGet cache I came back to, trusted signers. One thing I didn't tell you about trusted signers, are there any Mac OS or iOS developers here who are using MAUI, for example? People who are building on a Mac, like I do. Trusted signers has a bug, or a feature, for quite some years already, where the encryption stuff that they use to validate the signature of the publisher doesn't really work with the Apple encryption stuff. So trusted publishers, or trusted signers, I configured it on my machine, but I can put anything in there, it will break. On Windows and on Linux, the feature actually works, and it works great. But on macOS, it's just not working. And there are a lot of GitHub issues, or there's one GitHub issue with a lot of upvotes and comments on it, but it's not being picked up yet, or they're not able to fix it currently. What's in there. But if you're not using Mac, then trusted signers is working perfectly fine. What I didn't show you yet was the SBOM file. And looking at the time, I might be able to generate one for you. But the SBOM file is a bill of material, which is should be an output of your build process, and it contains all the package information that your product is actually using, including the licenses that are I'm just going to generate, because talking about it takes as much time as just showing you. So for this, there are a lot of tools. You can also use Trivy for it. There's this format, SPDX. Okay, there are different formats, and now for readability, I just put it out here. So this will actually tell you which package version you're using, and actually the same stuff that I showed you with the .NET NuGet of .NET List package, where you get certain package information. But the SBOM file is meant to be to provide insights in what you're using, but also to create observability for it, because this file can be uploaded to certain tools like dependency track or whatever, which you can then monitor your supply chain in production continuously with. You can imagine that if you have a certain service that you don't touch for 2 or 3 months because there are no features there to be built, you're not building it and you don't get any vulnerability information. But by creating an SBOM file and using it in the right tools, you can create continuous observability for your supply chain, and if there are any known new vulnerabilities that you are vulnerable for. So that's one. And what's a bit more recent is a concept that's related to SBOM file, which is the VEX. And VEX stands for the Vulnerability Exploitability Exchange. And this actually means is putting vulnerabilities into perspective. So you have a certain vulnerability database, you have your SBOM file, and let's say we have 200 vulnerabilities in our software. VEX then puts those vulnerabilities into perspective by saying, yeah, there are 200 vulnerabilities in my software, but our API is not publicly available, or there are certain measures in place why this vulnerability is not exploitable. And then it puts it more into perspective, and then we only have 5, for example, which are actually exploitable. So putting the vulnerabilities more into perspective and communicating to the world what the actual important vulnerabilities are, this is where Vex tries to fill in a gap. And to finalize, has anyone ever heard of the Salsa framework? Great. Salsa is a framework which was before only for package producers. And I heard this morning that the Microsoft consumer framework for stuff that Niels showed is included into Salsa, including the entire software development lifecycle, defining certain vulnerabilities, defining certain attack vectors for your supply chain, and also providing measures to implement this. So stuff that I showed you today is a small part of your entire software development lifecycle. So if you want to know more about what else is there to take into account and what are other vulnerabilities or other attack vectors that I need to take into account, I would definitely recommend have a look at Salsa. So what we've looked at, what you've learned, different types of supply chain attacks in .NET. The supply chain risk management. The next time, I hope that if you add a package, you might think twice. What's the impact of adding this package to my product? A secure by design setup with all the NuGet features I showed you and the .NET features where adding malicious or unknown packages to your software gets harder and harder. And creating transparency for the world to see using the SBOM file and the Vex file to put it into context. But start today, maybe tomorrow if you get back, or Friday, when you get back to your job, by taking a look at your packages, what are the vulnerabilities that we have there, and fix them before they get exploited. And the license stuff, that's also, I think, a small thing to do, but also great to have insights in. The thing I showed you, the demo, is on my GitHub. You can just find it there and look at all the examples I showed you today. Thank you for listening. And if there are any questions, I'm available all day. If there are any now, then please feel free. If not, thank you for coming. Oh, yeah?
You're not getting away with it. So the scanning for dependencies, including transitive dependencies, is there any way I can quickly implement that into my pipeline? And for example, output that as test results so that I can handle that as
So the question is, can I add the .NET the vulnerability scanning that's in .NET quickly to my pipeline, and can I output it as a test result? Sorry?
There is a specific format output test results. The format will automatically be, for example, Azure DevOps.
Yeah, the test result tab there. I have never done that. What you can do is put the treat warnings as error thing in place, and then the include transitive and -- vulnerable in your list package, or in your just .NET build process. Then your build will fail. There are no test results from there, but that's what we currently have. But it's an interesting thing to look at. But yeah, I'm not sure if that's possible currently. I've never done it, at least.
Just to add to that, depending on what's already in your pipeline, there are other tools that will do that as well, such as Sonar or similar.
Yep.
You can add those in to get results as well.
That's true. I know there are other tools. I was just wondering if you know the default .NET stuff, I can output that, use that. But to know more tools is also more.
One thing that is new, which is maybe interesting to add or at least look at, is the .NET package update. If you have the .NET package update was already there, but they added a new .NET package update -- vulnerable one, where they can actually look at all the. Again, I broke my build with configuring stuff, which you can actually tell NuGet to look at all my dependencies, see what is the fixed version of my vulnerabilities, and update my package to that version. So you get the automated update process that's stuff like Dependable does as well. Also, they're trying to get into that space a bit as well. And I saw you had another question, but I have one more thing. Because AI is also a thing, is that they announced at .NET Conf let me see where it is, NuGet MCP server, where you can actually currently get certain package versions, security updates, and version updates. So stuff that I showed you that you can do using .NET Build and .NET List and that kind of stuff. You can also ask an LLM to do that currently, but I'm not sure why this is a feature if they already have it in place, but that's a different discussion. Yes?
We have internal NuGet feeds, a private NuGet feed. If we spot vulnerabilities in our own packages and want to flag them up so that across the company no one's using that vulnerable package, is that something that's true? Is that optional? Do you know of anything that can count?
Sorry, if you have found a vulnerability and...
In our own package in a private NuGet feed.
Yeah.
So we can't pull from NuGet to get that vulnerability information, but is there something we can do to support something with NuGet audit that pulls from an internal feed that says this package is vulnerable?
NuGet Audit will only use the public NuGet feed to retrieve the vulnerability information. So it's still, even though if you're using the, let's say you have newtonsoft.json in your private feed and you use it from there, it will still go to the public NuGet feed to access vulnerability information for that package that's being pulled in from the private feed.
So we can mark our own package as don't use it.
You can create your own audit source. There's a whole documentation about what type of interface you need to provide with that, but there is possibilities to create your own audit sources. Yeah. Great. If there are no more questions, then thank you for joining me. And if there's any questions, please shoot me at the, don't shoot me. Come to me at somewhere in the conference. I'm easy to find, I think. Great. Thank you.